Hi, thank you so much for joining. And today I am going to start a new series. Basically, I'm going to go over my curriculum that I started a year ago, and I'm going to give it more structure. I'm going to explain some of the concepts that I felt need more explanation. And a lot of questions came, and I never had time to go back and answer those questions. So, as I'm restarting it, I'm going to answer a lot of those questions too. And over the year, I have learned a lot. So definitely when I'm looking back over the content that I created, and I think it definitely needs some restructuring. So especially when new people come join my channel and they see a lot of playlists. So sometimes they ask me, okay, where can we start? So my goal this time is it's not like I am going to create every video again, but I'm going to rely on already recorded videos a lot, but I'm gonna add new content, a few areas where I feel I didn't, there I need to give a little better background, better introduction, or need to focus on certain thing where I didn't focus previously. So that's where I'm going to jump in and I'm going to create new content. Okay, and also this will be this video is going to give you all that information about that. Okay, so this is going to be the first one. From the second video we will start a proper introduction and going to get into the topic. So in this video I'm going to explain you what kind of content overall I'm going to cover, tools used, duration for those. Okay, so I know a lot of people said, okay, I should keep creating content on physical design. But if I go back a year ago, what I started, I wanted to build a curriculum that gives undergrad students as well as fresh engineers uh, good foundational concepts, the concepts that I felt I was missing and wish somebody had taught me in a better way. So those concepts which are going to be the foundation for you. But later on, whether you go to RTL design or RTL validation or physical design or you go DFT, you can go on and take further advanced topics as you start working more, right? But the foundation at the field needs to be really good. So my goal was to build a curriculum where I cover digital system design, um, implementation in system Verilog, computer architecture, and then physical design. I take you through all those key concepts in a year time. And yeah, so last year, what I did was I started around, I think, June 2024. So by November 2024, I started creating physical design content because I had few trainings coming up, so I had to focus on that. And since November 2024 till now, and now it is July 2025. I've been focusing completely on physical design, and I have brought a lot of advanced topics to you also, especially in the area of STA. So I think enough on physical design. What I'll do is, sorry, not enough physical design. I will keep bringing advanced topics, or especially STA related advanced topics, once a week. So I will keep doing those videos, but my major focus from now on for a year will be on revamping that whole curriculum. So, well, I have some contents over there where I'm looking at. So, and you will have content here. So, the very first part will be on digital design and verification in System Verilog. My goal in that module, so overall I will have three modules. Okay, let me tell you: digital design and verification, and I will use System Verilog, and I will build RISC-V processor in System Verilog, and we will verify that. Okay, whether I will consider all the available instruction or will need to be a reduced one, we'll see. It depends on the time, how much time I take. But my speed will be little quicker, because I'm gonna give you some of the videos that I already have watched this one this week, and then at the end I will summarize. I will give you even quizzes as well. So second part will be CMOS, understanding transistor, and how different gates are made of transistor, how combinational sequential gates, and how memories are made. These topics I will cover in the second part. I really think understanding the CMOS transistor is really important for you to understand the core concepts of power, performance, area. Okay, and I will also give you exposure on the technology node. What is technology different? Last time I think I covered that scaling in a lot more detail, but I will see what are relevant parts are important for you to understand some of the modern latest technology nodes, and what are the how the transistor built there, and what are the some of the challenges there. So I think that knowledge, then digital system design and computer architecture knowledge, and then whatever we build first in system Verilog, we will start creating physical design of that. Even during the digital system design, or DDV, I will start doing synthesis. So during that part, so synthesis we will make part of the DDV, and when we do physical design, then we will start maybe physical synthesis, which can be physical, I should say physical aware synthesis we will do, and then place clock tree, CTS, route, STA, DRC. Those topics we will do later on during physical design. I think I tend to spend more time in this iteration over the front end design, because I gave less focus on that last time. So it will be first maybe 4 or 5 months will be very heavy RTL design, computer architecture concept, digital logic design concepts. But the core thing I want you, I will look into, okay, how to build a RISC-V, and for you to be able to build that, what are the core concepts you need to understand? That is really my focus going to be. So you being able to design RISC-V, that is my goal, and that is really the ultimate goal of my DDV course, not just going over the theory for the sake of going over the theory, you know what I mean? All right, so, and I will be using only open source tools. So I know I need to learn in this on these tools myself too, but this whole training, as I pick open source processor architecture, all the tools, whatever free is available. So we will focus on keeping things simpler, making sure all the concepts are included, but things are simpler, so that is implementation is simpler, and we really need to produce something which is high performance as well as super low power, because I think that will be the need of modern data centers, and especially AI, how we can reduce power. So that's where my focus will be, but it will be only open source tool. So let's see, whatever, I will figure out what limitations come, and then we'll see. So that is really the agenda. And by the way, yeah, this entire refresh, as I said, every week I'll bring few videos. I will give you tasks. Okay, watch this video, then maybe I will summarize those videos, or I will create a new video if I see that I didn't explain that well before, or some of the learnings I have after going over this curriculum for a year, and I'll give you quizzes as well. So for that, all that reason, I am making it paid membership, but the membership is the lowest rate that I could go, and that was $2.99. If you are in US, if you are in Europe, if you're in India, last time I look at, it's not equivalent of that, but I think it was around 60 Indian rupees per month. So in US, $3 for a month, for a year is $36, right? I think even for students here is very reasonable, and I'm sure that 60 Indian rupees a month and about 720 rupees for a year is not that big a deal. Now other countries, for example, Pakistan and Bangladesh, I see that you cannot get a YouTube membership with that country, but you know how to deal with that, right? So figure out, be smart. Okay, so that's all I have, and in the next video I will start with my whiteboard. I will start drawing things, and I start giving you some homework for the week, and what videos you need to watch and whatnot. But overall, in the next video I'll give you overall chip design overview, and then we will start digging deeper into that. All right, hope that was good. If you have any questions, please ask those in comments as soon as possible, and I will watch this video I'll make public for sure, and in between some of the videos I have to make public too, because I have to keep producing some free content. But these comments on these videos that I'm giving you, or if I ask you why these videos, I will keep a close eye on watching the comments. So I'm sure we'll have a lot of good learning this year, with a different angle or maybe different focus, and I will revise it, and every year I'll keep doing these type of them, and I'm sure that eventually the curriculum will come really good and great. All right, that's it for now. Thank you so much. See you next time. Bye.